Okay, we're working in section 4.2. We're going to move on to an important application of exponential equations, which is compound interest. I have a little problem here to help us understand what compound interest is and how it works. So in this first question, if you invest $100 at 10% interest, how much money do you have after 1 year? So in this case, the assumption is that you get paid the interest at the end of the year and that you get paid 10% of the principal amount, the $100. So you could write 10% of $100 is $10. And this is the interest that you earned. And then you already had $100 and you add 10 onto it, so then you have $110 total. And so compounding the interest just means that that the interest is going to earn interest. And so if we got paid our interest more often, then the interest could start earning interest sooner and we'd wind up with more money. So let's see how that works. Let's suppose you have the same situation here, $100 at 10% interest, and now you get paid interest every 6 months. So it's still a 10% interest rate. 10% is an annual interest rate, right? So that's how much interest you earn over a year, but you get paid that every 6 months. So that means you would get paid half of the 10%. So let's see here. So if we had 10% of 100, but then since we're getting paid after only 6 months, we only get that's half of a year, so we only get half of the 10%. Then that would be $10 times a half, which would be $5. Which is great because now you have $105 total. And I should have written up front, this is after 6 months. And then after 6 more months, then the $105 earns interest. So now, after another 6 months, we get 10% of 105, but only half of that because only 6 months passed. But now this is $5.25 of interest. And so if you take the 105 that you already had and you add on the 525 that you were paid in interest, now you have $110.25 in the account. And so that's more than if you were only paid interest at the end of the year. And so you can imagine that getting paid interest more often would be even better. It's not a big difference here on a $100 investment, but it can certainly add up over time. And so we'll see some of that as we'll get some idea of that as we go through the problems that come. So here is a formula for compound interest, and so it says if P dollars are deposited in an account paying an annual interest rate R compounded N times per year, then after T years, the account will contain A dollars. So let's see here. So P is the initial amount. Sometimes it's called the principal. A is the future amount, or sometimes called the future value. R is the interest rate. N is the number of times the interest is compounded, and T is the time in years. And so, it might be fun just to go and put that little example into this formula, just to see that we still get $110.25, just to see how that's working. So in the example we just did, right, we had $100. P was $100. And the interest rate was 10%, which we're going to write as a decimal, 0.1. And then N is the number of compounding periods. So every 6 months would be 2 compounding periods over the course of a year. And then T is just 1 year. And so if we put all that into our formula, then the future value is 100 multiplied by 1 plus R is 0.1 divided by 2 raised to the 2 times 1 power. And so you could use a calculator to simplify this. This probably isn't too bad. We can probably do this in our head. 0.1 divided by 2 is 0.05, plus 1 is 1.05. So 100 multiplied by 1.05 to the second power. And actually, the 1.05 to the second might be a little tricky. But if we square 1.05 and then we multiply that by 100, check on your calculator and make sure you get $110.25. Make sure that you're only squaring 1.05. The 100 is not getting squared, right? So order of operations says we apply the exponent before the multiplication out in front. Okay, so let's go on to example 4. We'll just change the numbers a little bit and see what we get. If we invest $1,000 earning 4% interest per year and it's compounded quarterly, then how much money will we have after 10 years? And so this time, let's see here, we're trying to find the future value, and we're given that the principal is 1,000 and the rate is 4% or 0.04. And what is N this time? If the interest is compounded quarterly, that's 4 times per year. So N is 4, and then T is 10 for 10 years. So we're going to take all of that and put it into our formula, and we'll have 1,000 times 1 plus 0.04 divided by 4 raised to the 4 times 10. And then we can simplify a little bit, and then we'll put the rest into the calculator. So 0.04 divided by 4 is 0.01, plus 1 is 1.01, and then the new exponent is 40. So raise 1.01 to the 40th power, and then multiply by 1,000, and you should come up with $1,488.86. And what we're doing here is we're rounding to the nearest penny. So that's 2 decimal places. Okay, finally, how much interest was earned over that 10-year period? Well, if we started out with $1,000 and we ended up with $1,488.86, then the interest, we can find the interest by subtracting. So we'll do $1,488 and 86 cents, and we'll subtract off 1,000, and the interest earned was 488 and 86 cents. We'll look at in the next video we'll look at a few more examples.